The craters of the Moon. Once it was thought they were formed by volcanic upheavals. The true cause is impacts from space. Mercury is the most heavily cratered planet, each pockmark recording a smack from the heavens. Most impacts happened when the planets first formed. These are Martian craters, imprints of primordial debris. From 4.5 billion years ago, the solar system was a maelstrom of colliding bodies, a bombardment that lasted 600 million years. But on our serene planet, where are the impacts? We have them, if you know where to look. Australia, dry and geologically stable, is one of the best places to find a crater. In the heart of the outback, these are the Henbury craters. They were blasted by an impactor that had broken into pieces. Most craters on Earth are quickly eroded by weather. These survive. The Henbury impacts happened just 5,000 years ago, evidence that Earth and the Moon are still threatened by projectiles from space. To find their source, we travel away from the Sun. Through space long cleared of interplanetary trash, we head beyond Mars. Out here, in the great void before Jupiter, is the asteroid belt. It's a vast disk of rocks, a ring of so-called minor planets. Were it not for the disruptive pull of Jupiter, the asteroid belt might have formed a single planet. As it is, orbiting between Mars and Jupiter, the belt is an array of potential projectiles. Gaspra is a typical asteroid. 20 kilometers across, composed of silicates and pure metal. Imagine it plunging to Earth. This one, called Ida, is twice the size. So big, it has a tiny moon on the right, named Dactyl. Dactyl, a chip off the old block. Twice the size again is Matilda, 52 kilometers wide, blacker than coal. It's the darkest we know. In false color, Vesta, brightest of all the asteroids. It's big, 530 kilometers in diameter. The dark part is a gigantic crater. Proportionally, if Earth had one similar, it would span the Pacific Ocean. Occasionally within the asteroid belt, there are collisions. Some of the resulting fragments can be ejected into orbits that carry them closer to Mars. Then, in repeated passes of Mars, an asteroid may be nudged into a new path, a trajectory that crosses the orbit of Earth. Such an asteroid has struck. 65 million years ago, it hit Mexico's Yucatan Peninsula. The result was a cosmic winter and mass extinction. When the skies cleared, 2/3 of all species were gone, including the dinosaurs. In false color, this is the crater, buried now beneath forest and ocean. The crater is 200 kilometers wide. The asteroid, which penetrated Earth's crust, was at most 15 kilometers wide. Earthly craters are best identified from space. This one has filled with water and formed a lake. Here, 2 lakes in 2 craters. And here, in crater-rich Australia, Wolf Creek. Preserved in the arid outback, the crater is 850 meters wide and some 300,000 years old. But that's young and modest compared to Australia's greatest impact site, which dates back 142 million years. Goss's Bluff, well over 20 kilometers across. In the United States, this is Meteor Crater, Arizona, gouged 50,000 years ago by a chunk of nickel and iron. Smaller projectiles reach us every day. Like this fireball, most burn up in the atmosphere and never make the ground. They can steal the show at a football match. Each year, 16,000 tons of debris rains from space. If a chunk lands, like this one, it's called a meteorite, burnt black in its fiery descent. This piece of solid iron was recovered when a meteorite detonated over Russia's Far East. It peppered the ground with cosmic cannonballs. Over North America, this one grazed the atmosphere and returned to space. Meteorites pose little threat. Asteroids do. A 1-kilometer projectile could wreak havoc. A dinosaur killer would wipe us out. So how do we protect our planet? The front line is here in New Mexico, where telescopes watch for intruders. The project, named Linear, is a joint venture of NASA and the United States Air Force, an automated system that scans for new asteroids. Thousands have been logged. Of crucial interest are near-Earth objects that are moving fast. An asteroid that could threaten the planet. Once identified, radar takes over. Dishes of the Deep Space Network bounce radio waves off Earth-crossing bodies. Size, shape, and rotation are logged. We must know the enemy. This one, Castalia, is like a peanut, possibly 2 asteroids touching. And like this one, Geographus, up to 1,000 near-Earth asteroids are more than 1 kilometer wide. Eros is the asteroid we know best, for we've paid a visit. This is real movie. Eros is 33 kilometers long. A space probe called Near Shoemaker has taken 160,000 pictures and seen 100,000 craters. With such a battering, it's not surprising the surface is like rubble, but the interior is rock solid. In 2001, the spacecraft landed on Eros. We've touched the enemy. Luckily, this flying colossus doesn't threaten Earth. But inevitably, there's an asteroid that does. And if we're vigilant, we may have time to deal with it. One idea is a curved reflector. We could focus the rays of the sun on a small spot. By causing a jet of material to erupt, the asteroid will be driven from harm's way. Another approach could be a little rocket driver. Like an outboard motor, it will be attached to the threatening asteroid, moving it to a safer orbit. But if time were really short, and we'd be hit within days, there's the nuclear option. A warhead could blast the asteroid. Trouble is, we might then have a shower of fragments heading our way. There's a cleverer idea. Instead of approaching head-on, we could launch a warhead to one side of the asteroid for a standoff detonation. If the calculations are right, the projectile would be shunted from its collision course. Currently, our planet is safe. None of the Earth-crossing asteroids so far identified is a threat. There are scares, but within days, when orbits are refined, new sightings have proved harmless.